Strategies for placement of acoustic treatment. The Sabine's equation for calculating reverberation time gives us an indication of the amount and type of material to be added to the internal surfaces of a space or a room to control reverberance within that space. But in addition to providing enough material, the location of the material in the space is very important. Let's have a look at the Sabine's equation for reverberation time. So the form of the equation that is used most often is reverberation time, or RT, is equal to 0.161 multiplied by the volume of the space divided by the total area of absorption in the space. So let's have a look at this equation in detail. What it's telling us is that the reverberance in the space, or the reverberation in the space, is proportional to the volume or the size of the space. So if you think of a big cavernous space like a cathedral or an indoor swimming pool, the larger that space, the more reverberant that space is. On the other hand, A, which is the total absorption in the space, and that effectively is all the surfaces in the space multiplied by their absorption coefficient or their absorptive properties in the space, summed together. So when you think of the total absorption in the space, if you add more absorption in the space, then the lower the corresponding reverberation time. On the other hand, if you take out absorption or you have more reflective surfaces in the space, then the higher the reverberation time will be. A classic example is a swimming pool, an indoor swimming pool, where you have a large volume and you have a lot of reflective surface finishes. These surface finishes could be the water surface itself in the swimming pool, or the tiled surfaces or concrete walls. So the less absorption we have in the space and the greater volume we have in the space, the higher the reverberation time. When considering the placement of the acoustic absorption in the space or absorptive surfaces, we have to think about the following attributes of the space. What the space is being used for. For example, classical music, speech, and amplified music. For classical music, which is natural instruments being played in a space, and we want to use the reverberance of the space to enhance that music. Speech, on the other hand, where we want that speech to be intelligible and clear to the listener, we want to control the reverberance in the space. Amplified music, which uses sound reinforcement or loudspeakers, we are not relying on the reverberance or the natural acoustic of the space to provide the playback to the listener. So in most cases, we want to include a measurable amount of acoustic absorption or absorptive surface finishes in the space. The next attribute is the distance between the source and the receiver. The shorter the distance between the source and receiver means the more likely you're going to get direct sound from that source to that receiver location with minimal interactions with the surface finishes of the space. On the other hand, the greater the source and receiver distance, the more likely there are going to be first order or second order reflections off the interior surfaces of the space, which affects the intelligibility or the sound being heard by the listener. The third attribute is the shape of the space. The shape of the space can give rise to particular reflection patterns in the space. And for example, concave surface finishes which focus sound to a point might cause hot and cold spots of sound within a space.